All right, so what we're going to do is we're going to talk briefly about 9.1.4b. And what I'd like to do is focus on problem 16. Now, one of the things I wanted to mention about problem 45, the quick answer and the wrong answer is always to think, oh, well, that's simple. If it's half as big as she needs, and she did that in 3 breaths, all she needs to do is do 3 more breaths. So basically, here's her balloon, and whatever its radius is, that radius is pretty much half what it needs to be. So right here, so we'll just go with diameter. So it has a diameter. This diameter is twice as big. So for it to, basically what we want to do is double the size. Now remember, when we're talking about the amount of breath inside, breath is a volume. It's the amount of air inside. And because breath is a volume, and volume is cubed, the scale factor has to be cubed. So the volume of the little one is 3 breaths. And in order to find the volume of this, how many breaths? What we have to do is we have to multiply the old volume of 3 by the scale factor cubed. Which is 2, and that has to be cubed. So 2 cubed is 8. 8 times 3 is 24 breaths. Now, I didn't actually mean to do that whole problem, and it's sort of crooked, and I apologize, but for the crookedness, not for the doing it. But there you go. I know that it seems like my recordings aren't that good. Part of it is this table is exactly 1 foot square, and it's got a big hole in it. So I do have some limitations in my home office here, but hopefully anybody who's bothering to watch these videos will find them useful. So for this video, though, I really want to focus on problem 46. I think I might have said 16 before, but it's not even 6 a.m., so I apologize. I'm still waking up. All right, so they tell us to draw a cylinder on the paper, and so drawing a cylinder, this is something I actually would have taught you in class. Draw an oval. It's not a very good one, but oh well. Draw some straight up lines. Draw another oval. There you go. 1 cylinder. It's not very pretty, but oh well. Now, we know that the radius, I'll draw it down here, that's from the center of the circular base. We know that radius is 6 inches. And we know the height is 9 inches. So we have to find the surface area, and we have to find the volume. Now, if we're going to find the surface area, well, actually, volume is one of the things we've done more with, because volume is pretty easy. All we have to do is figure out what is the area or the size of 1 layer, and then multiply it by 9 layers. Now, to find the volume, we have to remember that the base is a circle. And so we have to find the area of the base by using the formula for the area of a circle. Now, I always, I've been trying to come up with good ways to remember the 2 formulas, because there are 2 formulas for circles. There is 2 pi r, that's the circumference, and then we have pi r squared, and squared is always more, and that's what you're eating. So this is the crust, this is the whole pie, or in other words, this is the area. So It always confuses people because there's an R, and a pi in both of them. But if you remember that for area, which is what we're trying to find right now, the area of the circle, what we want to do is the area, the units are squared, and the formula is squared. That to me is the easiest way to remember which one is which. And again, I'll try to make this less crooked. Sorry. Okay, so we're going to find the area of the circle, because then we can multiply that by the height, which is 9 inches. That's the number of layers. And then we'll know the volume of the entire cylinder. And the nice thing is that some of these computations are going to help us over here. So volume often is the easier place to begin. Surface area, we've got to worry about all the round sides, the top, the bottom, so let's focus over here. So we're going to take pi, and then the radius, we were told the radius is 6 inches, and we're going to square that. And so 6 times 6 is 36. There's a pi. My units are inches, and that's squared because we're finding an area. So our volume is going to be 36 pi inches squared multiplied by our height, which is 9 inches. Oops. So 36 times 9, when we multiply those two together, we're going to get a number. And then we'll have a pi. Now I'm going to let you calculate 36 times 9, because I don't actually have a calculator other than my computer. And that's a pain in the butt, and I want you guys to do at least a little bit of the work. I'm not going to do it all for you. So you find this number times pi, and then inches squared times inches. That's part of why we end up with the units cubed. So this is going to be my volume, or your volume, after you calculate whatever 9 times 36 is. Now this is an exact answer because we left pi as part of the answer. We would have spent a lot more time on that, but, well, we all know that why we're spending as much time on things, so that's okay. Now, let's take a look at this cylinder. If I were to unfold the sides, I would have the top and I would have the bottom. So there's the top, here's the bottom, and in between, if I unraveled it, I would have this big rectangle. And so my surface area is going to be the area of this base. I'll call it B for base, but I have two of them, so twice the area of the base. And then I have to find the area of this rectangle. Now this rectangle, this H, that's the distance from the top to the bottom. But we have to figure out what this distance is, because we have to really multiply the two dimensions, the height times the width. And so that's where this comes in, because this distance is the distance around the circle, and that's 2 pi r. I'm just going to put a C for circumference. So I need to know the area of the base, which I happily already calculated over here. So I'm going to multiply that number, 36 pi inches squared, plus, now let's find the circumference over here. I'm going to run out of space here. So my circumference is 2 times pi, and my radius is 6 inches. So 2 times 6 is 12. We leave the pi, and then we have inches. So this is 12 pi inches. That's for the circumference, and then the height is 9 inches. So then 2 times 36 is 72 inches squared. And then there's a pi. Don't forget the pi. I put a pi there. And then whatever 9 times 12 is, so 9 times 12 will give you this number, pi, and inches times inches is inches squared. And then what we're going to do is we're going to add 72 plus this. Those two numbers added together, that will go at the beginning. Let's see. So whatever that number is at the beginning, 72 plus 12 times 9. Those two numbers together, so our surface area, I'm just going to put the space for the answer is here. It's going to have an inches squared, and it's going to have a pi, and then it's going to have whatever the arithmetic gets you. So we'll have to multiply 12 times 9, add it to 72, put that number there, and you have your answer. So now that we have a volume and a surface area, I'm going to talk you through this next part, because this next part is kind of just like, but without a pi, just like the final question on the Chapter 9 test. So if you get this, you're in really good shape. So let's see what we got. So here we are going to enlarge it. We're going to make that cylinder bigger with the linear scale factor of 3. So we want to find the volume of the enlarged cylinder. So that kind of goes back to what we were doing up here. We know that for volume, units are cubed. So we're going to take the scale factor, which is 3, cubed. That's 3 times 3 is 9, times 3 is 27. So if you make it 3 times bigger, the new volume is going to be 27 times the old volume. So this is the volume of the new one, is going to equal 27 times the old volume. And the old volume, that's up here. So I'm going to put this up here. So that's whatever you got when you calculated this number. So that number, you're going to multiply by 27. And so your new volume is going to be whatever your new number is. And there's still going to be a pi. And the units are still going to be cubed. So the units are cubed. So the scale factor is cubed. So we multiply the old volume by 27 to get the new volume. And I hope, as crooked as that gets, I hope that actually helps. Because what's going to happen on your test is you're going to get an object and you're going to have to figure out the volume and surface area. It's not going to be based on a circle. It's going to be based on cubes. So, and I'm going to be doing a video to go over finding the volumes and surface area of a stack of cubes. And then I'm going to also talk about what happens. Like if I were to double the dimensions of this cube, that means that instead of being 1 inch on a side, it would be 2 inches on a side. But if it's 2 inches on a side, I have not even doubled it yet, really, because I've now got 2 inches here, 2 inches here, 2 there, 2 there. That's great, but I've only got 1 here. So if I take 1 cube and I double the size, just like up here when I was doubling the size of the balloon, I ended up having to take the volume of the small balloon and multiply it by 8 to get the volume of the big one. So here, if I want to figure out what the new volume is of the cube, when I just double the size, when you double it, suddenly you have 8 cubes necessary to double the dimensions. Now, to double the volume would be different, but here we're saying if we make the cube twice as big, how much bigger is the volume? And think about the surface area too. The surface area of 1 cube, it's like a dice. So if you've ever played with a dice game, you know there are 6 sides to a dice. It has dots, 1 dot, 2 dots, 3, 4, 6 total. So now if I double the size, will my surface area be double? Well, the original surface area was 1 cube, and then I have 4 here. So each of my 6 sides went from 1 to 4. So instead of having 6, I now have 24. Or in other words, it got 4 times as big. Because when we're talking surface area, we square the units. So we square the scale factor, which is 2. 2 squared is 4. And that gives us this lovely stack of, here, I'll kind of give you some perspective here, sort of. There we go. Here's my lovely stack of 8 cubes that started life as 1 cube, but got doubled in size. and the surface area is 4 times as big, and the volume is 8 times as big. So it's never simple twice as big if, so you don't take the volume and make it twice as big. So this is probably one of the key lessons for the final question on your test. Probably 90% of your test is based on the worksheet 9.1.1c, the activity, and the rest of your test is based on what I just talked about here with this cube, because your test is going to be based on a cube, not a cylinder. So I hope this helped, and I'll be uploading this, and then I'm going to be trying to make a video for 9.1.5 A and B, and also for the review. Okay? All right. I hope it helped.